Okay, in this video, we're going to look at graphing lines using what are called intercepts. Graphing lines using intercepts. And so you can see I've got my graph paper here. You may want some if you're going to take notes. We'll start with a basic example, and we'll graph the line. Graph the line that has x-intercept 2, 0, and y-intercept 0, -3. And so I'll kind of explain the concept of intercepts as we go through the problem, but you can clearly see that they are ordered pairs. So I need to set up my graph paper here. And also, we have 2 points, so that's plenty to draw a line. So that's enough to graph the line. So we'll create our axes. So let's say this is our y-axis. This is our x-axis, right? And I need to set up a scale on each axis. So I need to go to 2 on my x-axis. So let's say that this is 1, and here is 2. And I need to go to -3 on my y-axis, so -1, -2, -3 right there. And I need to plot the points, so I'll use a different color for that. I need to plot the points, so at 2, 0, I get this point right here. 2, 0, I get that point, and 0, -3, I get this point. Now, one thing I want to point out is the x-intercept 2, 0, notice it's on the x-axis, and the y-intercept 0, -3 is on the y-axis. So let's graph our line, and then we'll revisit that concept. Grab my straight edge here. So if I connect these 2 points with a straight line, it will look roughly like this. Okay, going on forever in both directions. And so that is the line that has this x and y intercept. So what can we get about x and y intercepts from this? Well, what is the x-intercept? X-intercept is a point, meaning an ordered pair. So it's a point, an ordered pair, where a graph touches the x-axis, okay? It's an x-intercept, it's where it touches the x-axis. It doesn't have to cross necessarily. There are some graphs that come down and just kiss the x-axis and bounce back up. That can happen as well, so it just has to touch the x-axis. Now, what's an important property that all x-intercepts have if they're on the x-axis? Every point that touches the x-axis, if you were to look at them, they all have a y-coordinate of 0. You have your x value, let's label that as x. You've got an x value because it's an x-intercept, but the y value is 0. If you've got a highlighter and you're taking notes, you might highlight that, but that's key there. Okay, I'll put a star next to it. Every x-intercept looks like that. Similarly, the y-intercept, a y-intercept, you can have more than one in some cases. A y-intercept is a point where a graph touches the y-axis, right? And you can imagine the point for a y-intercept is always going to look like an x value of 0, comma, some y value. Okay, so that's kind of the idea that we're going to utilize through the rest of this video. I'm going to have you graph lines where I give you an equation and you've got to find the intercepts. Okay, so I won't necessarily give the intercepts as we go along. And the key is an x-intercept is always x comma 0 and a y-intercept is always 0 comma y. Okay, let's move on. We have several examples in store here. Okay. So, next example. Graph using intercepts. When we say intercepts, we mean x and y intercepts. And the equation is going to be 5x minus 2y equals 20. This equation is often called standard form of a linear equation. Now, the reason it's standard is because there's no fractions and you've got your x and y terms over here. I'm not really getting into that, but we're here, we might as well mention it at least. But now, how in the world can I graph this? This is a line. How can I graph this line using intercepts? Well, the first thing I need to know is, I know it's a line because the x and y's are both to the first power. There's no curvature to this graph. Okay, so I know it's a line. And because it's a line, I only need 2 points to graph it. So let's see if we can figure out any x-intercepts. X-intercepts, remember, always look like x comma 0. So what this means is, I don't know what x is, but I know y has to be 0. So I can plug 0 in for y, and I can solve for the particular x that goes here. So I get 2 times 0 is 0, so I just get 5x minus 0, which is 5x, equals 20. And dividing both sides by 5, I can see that x equals 4. So my x-intercept is the ordered pair 4, 0. Let's go ahead and plot that on our graph. I noticed with this fine point marker that my axis probably didn't show up very well, so I'll indicate the origin just with the dot, and then I'll label on my axes what scale I'm going to use. And I just got an idea that maybe we should go ahead and find our y-intercept first. That will give us a better idea of what all we need to fit on this graph. So let's actually do that next, but let's use a different color. Let's use green and look at the y-intercept. So the y-intercept we know is 0, y, meaning we can plug 0 in for x now. So we get negative 2y equals 20, because 5 times 0 is 0. Divide both sides by negative 2, and we get y equals negative 10. So our y-intercept is where x is 0 and y is negative 10. So we have both intercepts now. So I know I've got to go to 4 on my x-axis and negative 10 on my y-axis. So I might put my origin, my 0 point right there, and then I need to measure out 4 units to the right of that. So there's 1, 2, 3, 4. And I need to measure negative 10 units down. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's negative 10. And then I need to plot both points. So at 4, 0, this is my x-intercept in red. And at 0, negative 10, here's my y-intercept in green. And then, because I know it's a line, I can simply connect those 2 points with a straight edge. And so this is the graph of the line, the equation 5x minus 2y equals 20. We did it using intercepts. Now, intercepts can be pretty quick because you're just plugging 0 in. So it works really nicely with this standard form. However, you're not always guaranteed to get integer values, whole number values for x or y. You can get fractions. And so our next example is going to illustrate that concept. Okay, so next, let's graph using intercepts again. graph using intercepts. And let's look at 2x plus 3y equals 13. So this time I'm going to set it up a little bit differently. We're used to graphing with xy tables. So let's take that approach and let's set up our xy table. So when we do that, we'll have this sort of thing. And because we're finding intercepts, I know I'm going to plug in 0 for x for one point and 0 for y for another point. Okay? So if x is 0, this is kind of a shortcut now because this is in this nice standard form. If x is 0, then this 2 times 0 is 0 and goes away. So all I have is 3y equals 13. So to solve for y, I would just divide by 3. So y would be 13 over 3. Or as a mixed number, 3 goes into 13 4 times with 1/3 left over. So we have our y-intercept. Our y-intercept is the ordered pair 0, 4, and 1/3. Okay? Let's do the same thing for the x-intercept. We'll plug in 0 for y, so 3 times 0 is 0. So 2x equals 13. If we divide both sides by the 2, then we get 6.5 for 13 divided by 2. So our x-intercept is the point 6.5, 0. Then we just plot those points. So now I've got a positive x and a positive y. So here's my x, and then here's my y. I like drawing the axes. Okay, so x is at 6.5. So here's 1, 2, 3, 4, 5, 6, 7. So here's 6. Here's 7. So our point is at 6.5 right there. That's our x-intercept. And our y-intercept is at 0, 4, and 1/3. So here's 4. Here's 5. So 4 1/3 is about right there. And then we can polish it off. This is my favorite part. We can polish it off by connecting the 2 points with a straight line. And so this is the graph of the line 2x plus 3y equals 13 using intercepts. Okay, so we've seen an example, 2 examples in standard form where one of them we got integer numbers for x and y. The other we got what are called rational numbers, fractions for x and y. Let's look at some examples that are not in standard form. And what I'm going to do now is, well, I guess we'll go ahead and graph. That's easy enough to do. Let me clean up this graph, hopefully. There we go. So the next one, we will continue to graph using intercepts. Graph using intercepts, and we'll graph y equals 2x minus 9. Now we can graph this using intercepts. It's a line because y and x are to the first power. We only need 2 points, so we might as well use the intercepts, right? So let's give it a shot. So now let's take the same approach. X, y, 0 for x, 0 for y. Now if x is 0, 2 times 0 is 0, and we just get y equals -9. Y equals -9. So the y-intercept was simple here. It's the order pair 0, -9. Now the x-intercept, we have to plug in 0 for y. So now, if I plug in 0 for y, it's not quite as straightforward as it was before. To solve for x, I would write this out if you need to. You'd have to add 9 over here, and then you'd have to divide by 2. So we get 9 over 2, which is the same thing as 4.5. 4.5. So it wasn't in standard form, but it also wasn't too terrible to figure out. So we get 4.5, 0. And in the interest of time, we could plot those points and draw the line. I don't think we need to do that. We've already seen examples like this. So let's move on to the next example. Primarily, this video is to focus on how to find intercepts and what they are. However, some equations make that kind of difficult. So we're going to do another one where we graph using intercepts. And by the way, I keep rewriting the instructions because I'm being sensitive to those of you who are taking notes and need the time to write the instructions for each example. So I realize I could leave it here and reuse them, but I'm trying to do what I might expect a student to do if they were taking notes. So the next equation is y equals negative 1/3 x. And so that's not in standard form, but no big deal. We have y to the first, x to the first, so it's a line. And if we want to do it using intercepts, I know that I'm going to plug in 0 for x and 0 for y. If I plug in 0 for x, I get y equals negative 1/3 times 0. Well, that's just 0. So in other words, y equals 0. So our y-intercept is the ordered pair 0, 0. Now our x-intercept, we plug in 0 for y, makes this go away. And then to get x by itself, I have to divide by negative 1/3. So I've got 0 divided by negative 1/3. Well, 0 divided by anything is 0, so x equals 0. Write out those steps if that helps you. So our x-intercept is also 0, 0. So I want to do this example because sometimes your x and y-intercept are the same point, and the only place that can happen is at 0, 0. The issue with that is if you want to actually graph, you need 2 points. And we don't have 2 points here. So if I wanted to graph this, I'd have to get some other point. I'd need some other point. So intercepts don't always work because sometimes they're the same. So if I wanted to plot some other point, I'd have to plug a different value in for x or y besides 0 and see what I get. So what I'm going to do here is I'm going to pick a number for x because I want to pick a number that multiplies by negative 1/3 easily. So multiples of 3 might be a good choice. So maybe I would choose 6 for x, and then y would equal negative 1/3 times 6, negative 1/3 times 6, which is negative 2. So my other point would be the ordered pair negative 2, 6. So now I have 2 points, 0, 0, and some arbitrary other point, and I could plot those to graph the line. Okay, let's do a couple more examples. Sometimes your equation doesn't have both variables. Okay, sometimes your equation doesn't have both variables. So for example, you could have the equation x equals 3. There's no y at all. So in this case, if we want to set this up with intercepts, which would be kind of a weird set of instructions for this problem, but intercepts are a very natural choice when you want to graph something. So if I plug 0 in for x, then I get 0 equals 3. 0 equals 3. I can't solve that for y. There is no y. This is impossible. So I'm going to draw a line through this. I can't make x 0, meaning that there is no y-intercept. Not every graph has a y-intercept. And we'll see that when we go to graph this equation. Now, if I want the x-intercept, I'd plug 0 in for y. Well, there is no y, so the equation stays the same and says that x equals 3. There's no y to plug in, so this equation doesn't change. And that tells me that my x value has to be 3. In fact, if I were to list 10 ordered pairs on this graph, all of the x values would be 3. Okay? So x equals 3, so my x-intercept is the ordered pair 3, 0. Yet I still only have 1 point to graph this line, but I need 2. So if I want another point, I'd have to pick another ordered pair, another x or y value. Now, if I want to pick an x value, I have to pick x equals 3. And if this equation doesn't tell me how to calculate a y. Now what that means is y can be anything I want. So for example, y could be 4. So any y value works there. It's just that x has to be 3. So we get some other point now that is the ordered pair 3, 4. Now I do want to graph this one so you can see what happens. So we've got our x-axis and our y-axis. We've got the point 3, 0, 1, 2, 3. And we have the point 3, 4, so 1, 2, 3, 4. 3, 4 is up here. And so in this case, the line that we're graphing happens to be a vertical line. And you can see that a vertical line will never touch the y-axis because they run parallel. And that's why this line has no y-intercept. It never touches the y-axis, and you can see that now when you look at the graph. All right, so there are several examples of graphing lines using intercepts. We should really understand intercepts. Make sure if you want an x-intercept, you plug 0 in for y and solve for x. If you want an x-intercept, you've got to solve for x, meaning that you know y. And vice versa. If you want to know a y-intercept, you want to solve for y, so you plug 0 in for x. Okay? Keep that straight and you'll be good to go.